Okay, we're on Unit 5, Communications on the Web. We've already talked about protocols and the devices to communicate. Remember, we had devices that access in, and then we had the intermediate devices that move the traffic to the networks. We talked about addressing already. We talked about the different means of communication. We kind of talking about WANs and LANs while we're doing this, working through it. And today we're going to start talking a little more in the next couple sections about web pages and uploads and downloads. We talked about protocol suite. We talked about bandwidth. It's important to understand bits per second and how we pay for our connection to the internet, how we connect, and you should know the difference between intermediate devices and end devices. Those with printers, servers, and other types. We talked about the TCP/IP protocol in the videos on the outline and the other ones, and these data packets that move through the network. Real brief review, you have the data in there, actually what you're sending, and then that gets encapsulated by these layers of different kinds of addressing, and then even more addressing to get the information from your particular device, end device, to another end device, like maybe a web server. Okay, we talked about addressing and how important it is to understand the difference here. You have a private address typically on your device internally. You got private addresses, and then if your device needs to go out to the internet, then it gets a public address to actually go out to the internet. It comes back and it matches that public address up to your private address, and then your private IP address matches up with the MAC address of your particular device. So it comes back to you. Okay, rather than remember IP addresses, we can use domain names and domain name services to do that. All right. Today we're going to talk about network design and a little bit about technologies. A logical view of the network is typically what we draw to take a look at the network logically. Okay, the physical network design is how it's actually connected. And we're going to look at some other videos to deal with this, but let's just look at this. What I typically draw is I'll draw, a device. Okay, let's say a phone, or we have a laptop, and then eventually they connect into some intermediate device like a switch, which then maybe connects to a router, which then connects to something else. Okay, and maybe here's an access point. Let's say the access point's connected to the switch, this is connected to the switch, and this connected wirelessly there. Maybe we have some fiber optics here, and so forth. So we have this combination, but this is a logical picture. It doesn't show specifically how everything's connected. A physical diagram an engineer would have that would show maybe the PC, and the PC is hooked to a place in the wall, and then that's hooked to maybe a patch panel that has all these connections, and maybe then that connection's made to a switching device, and then that connects back to the patch panel, which connects here. It shows all of the physical connections, and then they usually have a book and so forth. We'll see some pictures of that later on, the physical connection, but you need to just be able to distinguish between those terms. We've defined these earlier, okay? So you should be able to distinguish when something where we're talking about it's in the same general area, typically governed by one particular company, and they have all their things hooked together and geographically close in the sense that maybe it's a campus like NIACC. It can be many acres, but we're all connected. And then WAN typically is over a larger geographical area, and you usually use a service provider. Now you might be able to do it without a service provider, which we'll talk about in a second, but you typically use a service provider. So we talk about these different types of designs. So we want to distinguish, for example, these without getting too technical. When we talk about things being wired or connected, we talk about wire and fiber optics. There's physically something connected here to here physically. You know, either the device, maybe a device here and a device here, and we have this connection. This would be a logical picture. The physical picture would be more detailed, like, you know, like I was just showing up here. Okay? Wi-Fi is a technology that uses radio waves to send the information through the air. Okay? This is very typical of how you would maybe have your laptop connected at the college. You maybe connect Wi-Fi to an access point. Okay? Or if you come on campus, you might have your phone, and you might connect your phone to Wi-Fi on campus. Now that is different than maybe LTE, like a 4G connection. A 4G connection, you have your tablet or your phone, and they send a signal to some tower somewhere that receives that signal, and then that tower probably has a wire eventually going into some equipment somewhere. So it's using a different technology than Wi-Fi. You really need to distinguish and not call them the same thing. You know, when you're using 4G to connect to the network compared to Wi-Fi. And it's even different when you're making a phone call. Okay? That signal moving across. Different setup. Now we also can use, let's slide this up just a little bit. We can also use a means of microwave. You can send microwave up to a satellite. So, you know, you could have Earth, and up here sits a satellite, send a signal up, send it back down. Okay? Or we can have maybe a tower here and a tower here, and we can send that microwave signal this way between the two towers. Okay, this can be fairly popular, this idea right here of sending a signal through the air between two towers. Okay, for example, I knew a company once, they had a tower one end of Mason City and a tower on the building on another end of Mason City, and they just sent the signal through the air. So they were able to keep those two businesses connected. It looked just like a LAN. You know, some people might call it a LAN. I'd still call it a WAN. You're not using another provider. But you are sending the signal over a longer geographical area. And as long as there's nothing to interfere with the signal in between there, okay, this works very well too. Of course, weather and other things can cause problems with this, or having access to the signal. You're in a steel bridge, and that signal can't get through that steel bridge. That's happened to people, okay? Or something goes through this signal, you know, an airplane flies through it, so maybe you have an interruption for a second. But we have these two waves. This microwave, very directional, it's point to point, but it can be sent across a shorter distance, maybe 30 miles. You know, you can connect those, or you can send it up to a tower and send it back down to Earth, which could be a really long distance between those. And they're both used. Okay, there are a few other combinations of these, but the thing I don't want you to have mixed up is how these work. So we can connect the devices. We can use this Wi-Fi, which is a limited distance, but can be used to connect your devices to a access point in the general area. Okay, whether it's outside somewheres or in a building. We have the 3G and 4G method of communicating, which is different than this. And then we have microwave, which would be a whole nother solution also. Okay? So if we were to look at the big picture, you can have, like for example here at the college, let's say this is the internet, and the college has a router with 2 connections into the internet to the Iowa Communications Network. And this would be a logical diagram. They have a they have a firewall. They have a few other devices too. They have a firewall, and then they have this multi-device here, a switch, and then on campus, this is connected, via fiber optics to different buildings. And so, the fiber may run through a couple different things. And then these switches, intermediate devices, connect computers in different buildings. And there could be more switches. This switch could connect to another switch, which then services a bunch of computers in a lab in one building. And maybe this switch is connected to another switch that connects a bunch of labs in another building, or a bunch of computers, and so forth. And then also on campus, connected to these switches, are access points, which allow people to connect wirelessly. And they actually run through a separate network, and they actually go out to the internet a separate way, where all the connected wired communications go out another way. So this is sort of a logical diagram. It's a little messy, but you can kind of see how eventually your network could build and how you'd have communications going out. Just as a side note, coming off of here, that's actually fiber coming from there. There's a router and a multi-layered switch and some switches connected here. And this is where we service PCs in the IT area. So where the area I teach, it's like a little cloud inside the bigger cloud of NIACC. That's it.